2 video notes on solving systems of equations and inequalities. Okay, so we're really going to look at a couple of different things here, and again we're going to use Desmos exclusively for our ability to go through this content. But first, before we do anything else, let's figure out what does it mean to be a solution, right? So a solution is a point or many points that make an equation or group of equations true, right? So a line is all the points that make an equation true. So for instance here, right, here's this line, right, like this linear equation that we did from way back when in the fall. So write an ordered pair that's a solution to the equation whose graph is shown here, right? Explain how you know it's a solution, mark your ordered pair on the graph. So we could do anything here, right? How about right there, right? 0, -3. So 0, comma, -3. Boom. Now, how am I going to submit? Well, I plotted the point and it was on the line. Now, do I have to do that one? No. Couldn't I have done, right here and been at 4, -2? Couldn't I have been over here and been at -4, -4? Right? So there's a whole bunch of points, technically an unlimited number of points or an infinite number of points. And why are they solutions? Because they're on the line. The x and the y value form a point that is on the line. Okay? All right. So how do we find it from an ordered pair, right? So write an ordered pair that's a solution to this equation. Right? Explain how you know it's a solution. Oh, I'm just going to pick a value for x. How about 1? Okay, so now I'm going to take this equation, so y equals -2x plus 3, and I'm going to put a 1 in here. Okay, so -2 times 1 plus 3. Well, -2 times 1 is just -2. -2 plus 3 is +1. So I just get y equals 1, right? Excuse me. So if y equals 1, how do I know that that's a solution? Well, that meant when x was 1, y was 1. So what is my solution? So write an ordered pair that's a solution, 1, comma, 1. How do I know it's a solution? I plugged in the x value and got the y value out. Okay? Now, did I have to use 1? No, I could have put a 0, I could have put a 2, I could have put a -1, I could have put whatever here, right? And I could have kept getting unlimited answers, which is why it forms that line and why it keeps going on forever. So what about when there's more than one line, which is what we want to get to? Because really, screens 2 and 3 were like review from before. So what happens here? So an ordered pair that's a solution to the systems of equations graph are shown here. How do you know it's a solution? It's where they intersect. So that's the point. So what's that at? 2, 1, right? So how is this solution? It's at 2, 1. It is where the lines intersect. So when you have what's called a system of equations, it is where the two lines intersect, because that is where, and it is the only point where both equations are true. That xy value at 2, 1 would make the one line that's going kind of more up and down true, but also the one that's going kind of more left and right. It would make the positive slope line and the negative slope line both true. And no other point does that. There's other points that would make one of the lines true, but not both. So, how do we find that when there's no graph? Well, just like we had done before, we make a graph. So we open our Desmos calculator, which I've already done here, okay? And now I'm going to just take these two equations. So here and here. I'm going to type each on a separate line. So 2x minus 3y equals 7. So let's do it. So here we go. So I'm going to type in 2x minus 3y equals 7. So 2x minus 3y equals 7. 5x plus 3y equals 0. So then I go down there, I go 5x plus 3y equals 0. I'm looking for where they intersect. I click on it, okay? Now, double check that you have the lines correct, because oftentimes when people get something wrong here, it's because they typed in the wrong equation. Like, oh, it's supposed to be minus 3y, and I typed plus 3y, or, whatever. So there's the answer, -1, -1.67. So how many answers it have? It has 1. Okay, so that's one solution. What is the solution? Well, we just found it. We click on where they intersect. 1, -1.667, right? So 1, -1.67, okay? All right, and that's what we're looking for when it's a system of equations, all right? All right, so again, here's another one, so we can try this. So x plus 3y equals 5. So x plus 3y equals 5. You can see how the lines are changing in terms of the slope and the y-intercept, right? All right, and then negative 2x minus 6y, so negative 2x minus 6y equals 1. Okay, so notice what's different here. Where do these lines intersect? Well, even if I keep zooming out, do they ever intersect? No, they do not. So since we're trying to find where they intersect and they don't intersect, it's no solution, right? So what's the solution? No solution, right? And why is that? The lines never intersected, right? We're trying to find where they intersect. They don't intersect, so then we can't answer. All right, and then lastly, let's try this one. So 0.25x. So here we go. 0.25x minus 0.5y minus 0.5y equals 1. And then we've got negative x plus 2y, so negative x plus 2y equals negative 4. So watch what happens here as I change this 1 to negative 4. Boom. They're the same exact line. So every point here is also a point on this line. They're the same line. Now they have different numbers here because we made a decimal, right? So like this one is just this one if we multiplied it by 4. It's the same thing here, right? We've just changed the signs, we've changed the numbers, but it's like saying 1/2 and 2/4 and 4/8. They're just different representations of the same thing. So they interact everywhere. So in terms of this, how many solutions have we? Have infinite. So our solutions are infinite. Normally you'd say infinitely many, okay? So infinite solutions. All right? Because they just were the same line. All right, so in summary, what do we know? When you graph this and it's a system of equations, there are only 3 options. It can look like the first screen. They cross in one place, has one solution. The lines are parallel lines, so they never cross, no solutions. Or literally it is just a different version of the same line, so when you graph it, there's only one line that shows up, which is an infinite number of solutions. Okay, those are the 3 options. So again, now as we shift gears, we're not going to just do a system of equations, we're also going to do a system of inequalities. All right, so let's go backwards to what is a solution. So solution is a point or many points that make an inequality or group of inequalities true. So now, with an inequality, if you remember when we graphed inequalities, we're going to have a whole shaded area. Everything in the shaded area makes the inequality true. Remember that a solid line is part of the solution. A dotted line is not part of the solution. Okay, so let's go to screen 10. Write 2 ordered pairs that are solutions to the inequality graph shown here. Okay, now remember, it can't be on this dotted line because that's a dotted line that's dashed. Okay, so how about right there? I'm going to pick that point, and how about, I don't know, whatever. I can pick wherever. So what is this at? Negative 2, 2. So there we go. How about negative 2, 2, and what's my other point at? Well, I went left 1, negative 1. I didn't go up and down at all. Negative 1, comma 0. Now, did I have to pick those points? No, gosh, no. I just picked them because they were in the shaded region. So my points are in the shaded region. Okay? And they can't be on the dotted line because it's a dashed line. All right, so let's try it again, right? Now, let's look at it in a different way. A non-solution. So let's mark 2 points that are not solutions. How about I go like over here and over here. So how about 4, 0? So how about, 4, comma 0, and how about I just go like right here, 0, comma negative 3, right? Now in this case, because we want ones that are not solutions, anything on the line, so like 0, 0, would be a non-solution, so that would work also. Okay? Alright, so now let's look at it when we have the shading again. Okay, so how do I find a solution? So what if I want to say, where's a solution? Type a coordinate point in here. So how about 0, 0, right? So if I type in 0, 0 here, everybody see that dot? So let's label that. Boom. Is that a solution? Sure, of course it is. Now I'm going to change these numbers up. What about 4 zeros? That? No, it's not. What about 3? Well, that's on the dotted line. It's a dotted line, so that would not be a solution, right? So you can check any of these. If it's in the shaded region, it is a solution. If it's on a dotted line, it is not a solution. If it's on a solid line, it is a solution. If it's in the non-shaded region, it is not a solution. Right? So what about here, right? Graph an ordered pair that is a solution. So here's this graph. Well, let's find a point that's in the, let's just type some stuff in. How about 3, 2? Is that it? No. How about 3, negative 2? Bang. Yep, sure. There we go, right? So again, just checking that based on the graphing. Okay, so now what happens? What about when there's 2 inequalities? Okay, so look at the screen here. Now we need to mark an ordered pair of solution to both. So notice how there's the blue shaded part, which is really this part and this part, and the red shaded part, which is this part and this part. To get a solution that is for both of them, we need it to be in the part that would be shaded by both the red and the blue section. So it'd be down here. So how about 2, negative 2? The point would be right here, and that would be in both the shaded regions. So how about that? How about 2, negative 2? Okay. And why would that be? It would be because it is a solution for both shaded regions. Okay? So it would be for both of them. All right, so here we go. Kelly claims that 3, 0 is a solution to the system of inequalities. Is she correct? Sorry. So 3. So that's on where the lines intersect, right? So for the red graph, that is a solution because it's a solid line. For the blue graph, it's not because it's a dotted line. So no, it's not because the blue line is dotted. So it is not a solution, right? Dotted line, not a solution. So that point would not represent a solution. If both lines were solid, it would be a solution, but they have to both be solid. Okay. Okay. So right here it says right now the orange point is not a solution. In order to fit for it to be a solution in the system of equalities, it has to satisfy both systems of equalities. Move the point to make it a solution. So is it a solution here? No, no. What about here? No. What about here? No. How about here? Yes. It has to be in the shaded region for the red and the blue graph, which really means in this purple zone, right? So that's really what we're looking for. Okay, so which graph correctly displays this? Okay, well, what do we do here? You want to graph the same way. It's asking us, hey, which one is showing this the correct way? Graph these in our Desmos, and let's pick the one that makes the most sense. So here we go. Y is less than negative 2x minus 3, so I'm going to go back up in here, and here we go. Let's just type that mess in here. So y is less than negative 2x minus 3, okay? And then y is greater than or equal to 1/3 x plus 2. So y is greater than or equal to 1/3 x plus 2. So let's go 1/3 x plus 2. Okay, so we need it to look like this. So no shading, half shading, solid shading. So let's make sure that looks like that. So no shading, half shading, solid shading. And now, so I like my bottom two scenarios. Let's make sure the dotted lines match up. So we need this line to be dotted, this line to be solid, this line's solid, this line's dotted. Which one matches up? So let's go back here. Solid line for the positive slope, dotted line for the negative slope. Solid line for positive, dotted line for the negative. There we go. That's our answer right there. Okay? All right, so again, how would these look like in terms of on an SOL? Well, they'd look like these types of questions. So which graph best shows the solution to the systems of inequalities above? Type it in the calculator on Desmos. So 2x minus y is greater than or equal to negative 1. So let's go back up in here. Same thing. I'm just going to create it. So 2x minus y is greater than or equal to 1. And now I do my second line, and I see it's 2x plus 3y is less than 6, less than or equal, sorry, less than or equal to 6, so 2x plus 3y is less than or equal to 6. There we go. This is what this should look like. Now, where is the system that's the solution? Remember, it's the part that's double shaded, so it should be this part down at the bottom. So which one represents that? Boom, 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 bottom. There it is. Boom. That's the one that looks like the one we just did, right? So it's the same stuff here, right? Hey, isn't this just another version of the same problem, right? 2x plus y is less than -5, so 2x plus y is less than 5. Oops, -5. Do make sure you're really careful with that type of stuff. It's easy to get a wrong sign and then we mess it up. X minus 4y is less than or equal to 12. So x minus 4y is less than or equal to 12. And I do like to just double check. Okay, I got it right. Okay, what do I have here? So if you can't see it well, you can just drag it and move it, or you can always just zoom out. That works too. Okay, so the positive slope is a solid line, the negative slope is a dotted line, and the shading's in the upper left. All right, so let's pick that one. So I need the shading in the upper left, so it's got to be either C or D, and then we got to get the lines correct. So let's go back here. It's positive slope solid, negative slope's dotted. Positive slope solid, negative slope's dotted. These are both solid. Boom, there we go. Alright, so then lastly, you get questions like this. What's the solution here? What do? Put it in the calculator. Notice this is an equation, so it's just going to be where they intersect, right? So x plus y equals 4. So we go back up in here. X plus y equals 4. And then we go to what? X minus y equals 6. So here we go. X minus y equals 6. I double check that I have the right stuff. I do. I click where they intersect. Bang. 5, -1. 5, -1. There we go. That's it. All right, so then lastly, what is the number of solutions for the system? Well, there's no shading, so it's just where they cross. Well, here's where they cross at 3, -2. Well, how many solutions? And notice what it said. What is the number of solutions? Well, there's just one. So it'd be D. Okay, so then for the practice, you want to follow this link for the quizzes. Do the quizzes. You can do it more than once if you need to try and improve your grade. Make sure you complete that so you get your asynchronous work done. Hope this helped.